Wireless power transmission is the process of transmitting electrical energy from a power source to an electronic device without the need for physical connections like wires or cables. This technology is aimed at eliminating the constraints of traditional wired power distribution and enabling more convenient and efficient charging or powering of devices. There are several methods and technologies for wireless power transmission. Inductive coupling. This method uses electromagnetic fields to transfer power between two coils of wire that are closely aligned but not physically connected. It's commonly used in applications like wireless charging pads for smartphones and electric toothbrushes. Resonant inductive coupling. This technique uses resonant circuits to improve the efficiency of power transfer over larger distances. It allows for more flexible positioning of devices and higher power transfer rates. Radio frequency, RF, energy harvesting. RF energy can be converted into electrical power using antennas and rectifier circuits. This is often used for low-power devices like sensors and small electronics. Microwave power transmission. Microwave frequencies can be used to transmit power over longer distances. However, this method requires precise alignment and is typically used for specialized applications like solar power satellites. Laser power transmission. Lasers can be used to transmit power by converting light energy into electricity at the receiver's end. This method has potential for long-range power transmission but has limitations due to atmospheric absorption and safety concerns. Resonant magnetic fields. This concept involves using resonating magnetic fields to transfer energy over short to moderate distances. It has been proposed for applications like charging electric vehicles while driving. Wireless power transmission has a range of practical applications. Wireless charging, charging electronic devices like smartphones, wearables, and electric toothbrushes without the need for physical connectors. Electric vehicles, enabling electric vehicles to charge without physical contact, either while stationary or even while in motion, dynamic charging. Medical devices, powering implanted medical devices like pacemakers and hearing aids without the need for surgical battery replacement. Industrial automation, powering sensors and devices in remote or hazardous locations without the need for frequent maintenance. Consumer electronics, enabling more flexible and convenient arrangements of devices in homes and offices. Space applications, transmitting power from solar panels on spacecraft to other parts of the vehicle or to other spacecraft. Despite the potential benefits, there are challenges to overcome in terms of efficiency, safety, regulatory considerations, and the technical limitations of different methods. Additionally, there can be concerns about electromagnetic interference, energy loss, and health risks associated with high-power wireless transmission methods. Researchers and engineers continue to work on improving these technologies to make wireless power transmission more practical and widespread. Wireless power transmission, the technology of transmitting electrical energy without the use of physical conductors, has made significant advancements in recent years, but it still comes with several limitations. Efficiency. Wireless power transmission systems often suffer from energy losses during the transmission process, which can reduce overall efficiency. These losses can occur due to factors such as distance between the transmitter and receiver, alignment issues, and the type of materials between the two endpoints. Distance and range. The efficiency of wireless power transmission drops off as the distance between the transmitter and receiver increases. This means that the technology is most efficient when the devices are placed relatively close to each other. Achieving efficient power transmission over long distances remains a challenge. Energy concentration. In order to efficiently transmit power wirelessly, the transmitter and receiver need to be properly aligned. This can be challenging, especially when dealing with moving objects or devices that are not consistently positioned. Interference and compatibility. Wireless power transmission can be affected by electromagnetic interference from other electronic devices or sources. Moreover, different wireless power transmission technologies might not be compatible with each other, leading to potential conflicts. Health and safety concerns. There have been debates and studies regarding the potential health effects of exposure to electromagnetic fields generated by wireless power transmission systems. While many systems operate within established safety limits, this is still an area of concern for some individuals. Limited power levels. Current wireless power transmission technologies are generally suitable for low to moderate power levels. Transmitting higher power levels wirelessly is more challenging due to increased energy losses, safety concerns, and regulatory considerations. Cost and infrastructure. Setting up wireless power transmission infrastructure can be expensive, requiring the installation of transmitters, receivers, and related components. This cost can limit the widespread adoption of the technology, especially for consumer applications. Environmental impact. Depending on the technology used, wireless power transmission systems might still require the consumption of energy from traditional sources, such as fossil fuels, to generate the electricity being transmitted. Regulatory and standards challenges. Developing standards and regulations for wireless power transmission to ensure safe and efficient operation across different devices and industries can be complex and time-consuming. Weather and environmental factors. Environmental conditions such as rain, snow, and other weather elements, as well as physical obstacles, can affect the efficiency and reliability of wireless power transmission. Security and privacy. Wireless power transmission systems can potentially be vulnerable to hacking or unauthorized access, leading to concerns about device security and user privacy. Despite these limitations, ongoing research and development in the field of wireless power transmission are striving to overcome these challenges and improve the technology's efficiency, safety, and practicality for a wide range of applications.